Hi friends, I am Muralidharan and welcome to my channel. Before going to the video, please subscribe to my channel, like, share and subscribe. And today in this video, I will tell you how to pass HMT in one night. And without any evasion, we will go to the topic. And we can see our first module. In first module, we need to learn the Fourier law of conduction and explain the types of mass transfer with example and explain briefly Phillips law of diffusion. And in the second unit of the first module, they will ask explain Newton's law of cooling and derive the governing equation for convective heat transfer. And briefly explain Stephen Boltzmann's law and explain combined heat transfer mechanism. In first module, they won't ask any problems, and if you have any problem, then go for the theory, and they will ask any one problem in whether they ask that in one module or in the one unit or in the second unit. Let's go for second module. One end of the long rod is inserted into the furnace, and it's a problematic one whether here we need to calculate the thermal conductivity K of the given rod, and they are given the length of the rod and they are placed apart 75 centimeter and the temperature between the plates and the temperature, and they are given the diameter of the rod. And in the second question, we need to derive the three-dimensional general heat conventional conduction equation in Cartesian coordinates. And next question, we need to derive the expression for instantaneous heat transfer and total heat transfer using lumped analysis for unsteady heat state heat transfer to the body from the surrounding. And in the second unit of the second module, we need to derive the expression for temperature distribution and the heat flow through a fin of uniform cross section with the end insulated. And in the second question, we need to know a rod. They have given the rod diameter and the length of the rod and the temperature, and we need to determine the temperature of the rod and the heat dissipated rate and the effectiveness. And in third question, we need to derive the three-dimensional general heat conventional equation in a cylinder coordinates. And in the third module, we need first question obtain empirical expression in terms of dimensionless number for heat transfer coefficient in the case of forced convection heat transfer. And the second question is a problematic one. We need to calculate the following kind of test like boundary layer thickness, average friction coefficient, thickness of thermal boundary layer, rate of heat transfer from the plate between x is equal to 0 and x is equal to x. And here in the sixth question of third module of second unit, we need to explain the velocity boundary layer and the thermal boundary layer, where we need to explain briefly of the velocity boundary layer and thermal boundary layer. And in the second question, we need to explain the significance of the following three numbers, that is Graphion number and Nusselt number and Branton number. And the third question is a problematic one where we need to find the value of the conventional heat transfer coefficient of the following plate, and they have given the dimension of the plate and we need to find the temperature. They have given the temperature, we need to find the conventional heat transfer coefficient. And in the fourth module, we need to seventh question where we need to derive the expression of the LMTD for a parallel flow heat exchanger with assumptions. And we need to find the what is meant by fouling factor in a heat exchanger and what is its effect on a heat exchanger. And the third question is a problematic one where they have given the value of the tubes and the inner diameter and outer diameter of the tube, and they have given the flow of the through a pipe and the cooling fluid to the analogous opposite direction at the rate, and they have given the rate of flow and the temperature. Then they have given the surface heat transfer coefficient from the oil to the surface. They have given the heat transfer coefficient, and the metal, and from the metal to surface they have given the heat transfer coefficient. And in the second unit of the fourth module, where we need to explain the Stephens-Boltzmann's law and the black bodies briefly, and obtain an expression for the rate of heat transfer when radiation shield is introduced between two parallel planes. And the next question is a problematic one, where we need to calculate the percentage reduction in radiation when heat transfer as a result of radiation shield, which we have to solve using data handbook. And the previous fourth module third question, the where an oil cooler consists, that problem was to be solved from the data handbook. And it comes to the fifth module, where we need write a short note on aerodynamic heating and the problem. And the last question is on diffusive heat mass transfer with neat diagram, and write a short note on ablative heat transfer. Thank you guys for watching this video. Please support us. Please like our video, share and subscribe.